This is the first FRQ. So I think that this one's gonna be the one that's on the test because it's kind of like in the middle of like what we learned. So it's like linear regression, scatter plot, printed table, equation of the line, correlation, y-intercept, best fit line, and residual. So when you first get this FRQ, the only it's gonna have like an introduction, but it's gonna have this table. It's like the printed computer table, and it's gonna have two graphs. This one's the scatter plot, and this one's the residual. So this is from chapter 3. I was looking at my tests, so I just copied all the questions and answers. So it says, what's the regression equation? Define your variables. So whenever you see regression equation, it's this one. So it's y hat equals a plus bx. This is the LSRL, or the regression equation formula. So basically what it's saying is like y is your predicted value, a is your y-intercept when x equals 0, and b is your slope. So if it's saying what is the regression line and to define your variables, it's referring to this one. And what it's asking you to do is to plug in your x and y. So back to this graph, this is the scatter plot. It gives you the x and the y. So you just plug that in, and you have to do the hat. So since this one's y, I put squirrels per plot because this was on the y-axis. And then I put equals, and then on the table, it's going to give you all these numbers. And so the only ones you really need are this one, which is A. This one's always going to be your A. This one's going to be your B. And this is your R squared. There's two of them. There's one that says R squared and one that's R squared adjacent or whatever. I don't know what that stands for. But you're not going to use that one for this. You don't need this. Okay, so since this is going to be your A and this one's going to be your B, you're going to plug it into your equation. So we already did y. So A is going to be negative 15.553. So you're going to put that there. You're going to plus, and then it's your B, which is this number. It's going to be 0.135. And then X is going to be the X on the scatter plot, which is the percent of trees. So you just put that in parentheses. So since it's saying to define your variables, or like to add context, that's what it means. It means like you have to like write what it's like what the equation is talking about. So like this one's talking about squirrels and percent of trees. So that's gonna be how you answer the first one. Okay, so the next question is find and explain the correlation coefficient, which is R. This correlation coefficient is R. So the table, I talked about R squared. They gave us a percentage, so it's 70.9%. So this isn't R, this is R squared. And so since they gave us a percentage, we have to change it into decimals. So you do that by moving the decimal point 2 places to the left. So it went from being 70.9% to 0.709. So that's R squared. But it's asking for just R. So what you're going to do is you're going to get your R squared, which is R squared equals 0.709. And you're going to square root it, both sides, to get R by itself. And then you're going to get 0.842. And so the correlation coefficient, what it's saying, it's telling you if the graph is like weak, moderate, or strong. And so over here, I wrote, if it's 0 to 0.5, it's weak. If it's 0.5 to 0.8, it can either be moderately weak or moderately strong. So like if this was like 0.6, I would describe it as like moderately weak. But if it was like 0.79, I would be like moderately strong. And then 0.8 to 1 is just strong. So since ours was 0.842, that would be in this one. So that would make it strong. So it says find and explain the correlation coefficient. So we found it, right? And we know that it's strong. So now we just have to explain it. So I wrote that the relationship between the percent of trees harvested, which is your x, your x, and squirrels per plot, which is your y, is decreasing. And we know this because the graph is like it shows that it's decreasing. It's linear because we see again the graph is right there and it's linear. It's not like a curve, so it's just straight, so it's linear. And then we're gonna say that it's strong with a correlation coefficient of 0.842. So you have to say whether it's weak, moderate, or strong, and you have to say what the correlation coefficient is, which was 0.842. And you have to show your work, so you're gonna need to write this down too. But that's how you do B. Okay, so now we're on C. It says, what is the slope of the regression line? Interpret in context. So your slope is going to be your B. So we wrote it over here. In the formula, it's B. And then in this equation that we wrote with context, it's going to be 0.135. So if we go back over here, it's what is the slope of the regression line? I always write it like this. I don't really know what this means, but I think you should write it because it makes it easier when you explain it. So I put 0.135% right here, our B. Remember, we got this from over here. And then since I'm going to add context, so I'm going to also include the X. So I'm going to say 0.135% trees are harvested for every one squirrel. It's always going to be 1 on the bottom. I left it as a percentage. I think you can do it either or, like percentage or decimal point. I just thought it was easier to leave it as a percentage. So then when you explain it, you're saying that for every additional squirrel, there are 0.135% of trees harvested. So that's it for this one. Okay, so now we're on D. It says, interpret the value of r squared in context. So this one, we're going to go back to our table. Remember that they gave us r squared. So we said it was 70.9% or 0.709. This was before we changed it to just r. So this one, you're just getting it from the table. So it says, interpret the value of r squared in context. So again, our r squared is 70.9%. I left it as a percentage. So I said approximately 70.9%. And this is going to be your X. Or no, this is going to be your Y. Approximately 70.9% of squirrels per plot is explained by the linear relationship of percent of trees harvested. Okay, so now we're on E. It says, describe the association shown in the scatter plot between percent of trees harvested and squirrels per plot. Use context. So for this one, we're going to use Duff's. D stands for direction, increasing, decreasing, or if it's flat. Unusual is gaps or outliers. Form is linear or curved. S is strength, whether it's like strong to weak. And then we have to add context. So this was what they gave us. It was it decreasing, and this is the X, this is the Y. So it's saying to just describe it. So you're going to have to remember to include all of these things. So I just restated this, and I said the association between percent of trees harvested and squirrels per plot seems to be decreasing. You're just going based off of what the graph looks like. And there doesn't appear to be any potential outliers or unusual gaps. So usually for this one, all of the points were close together. So I said that there didn't seem to be any gaps or outliers, but you want to like use like a wiggle word. So like I'm saying that it doesn't appear, because there might be, I'm not sure, but like I'm going based off what just the graph looks like. So then I also say potential, and yeah. And so that was your U. And then for form, I said the relationship is approximately linear. And then for strength, I said strong, because we already figured out that it's strong using R, but that's for E.